All right, in this problem, I've got some liquid in a cylinder, right? And then I'm going to pour this other liquid on top of it. And because this liquid is less dense than the other side, it takes more of it to make it weigh down, right? So they're going to be kind of uneven. Okay, so the first thing I'm trying to figure out is L. So the first part of this is find L, which is the height of this, right? That's L. Okay, so this is just kind of a geometry problem. So this part right here, that liquid, imagine that liquid. That liquid is a cylinder. And the area of a cylinder equals, the volume, I shouldn't say the area, the volume of a cylinder equals the area times the height, right? So the area, it's this area times that height. That'll give me the volume of a cylinder. And the height is what we're calling L. That's what you're trying to find, right? So I can say volume equals area times L. Okay, I know the area, because see how it tells me minus 5 cubic square centimeters? If I could figure out the volume, then I could just divide over the area and solve for L, right? Okay, so how can I get the volume? Well, I know the mass and the density, right? So you know density is mass divided by volume. And it tells me the mass, right? That's the mass of the light liquid. So mine is 100, right? So if I know the mass and I know the density, it tells me down here, and it also tells me in the problem mine is 1. If I know the mass and I know the density, I could solve for volume, right? You can do algebra and solve for V. And then once I know volume, I can take this volume and I can plug it in here. And now I'll know volume and I'll know area because it already told me the area, and I can solve for L. And it's it's in centimeters, so just be careful. You need to turn your meters into centimeters, right? Always be careful with that when it asks you. So that one wasn't too bad. It's just a geometry problem. So the second part says, I want to find this difference in height right here, H1. So there's a height of the lower liquid and a height of the upper liquid, right? So this is a pressure problem. So the pressure of the heavy liquid equals the pressure from the light liquid. All right. So this is still fluids, right? So pressure is density times G times height, right? So I'm going to say density times G times the height of the heavy liquid, right? So what am I going to call the height of the heavy liquid? Let me do this. Density times G times, what can I call delta Y? So delta Y for the heavy liquid is from here to here. That's H1 plus H2. That's my height for the heavy liquid, right there. See? Right there is where I'm cutting it off. I'm measuring these two heights. So this one is H1 plus H2, and this one is L. So that's going to equal density times G times L, which I already know. I know this whole part right here. Everything right here you know. You got L in part 1, G is 9.8. The density of the light liquid is whatever it gives you down here, right? So this is a known number, right? If you wanted to, you could just calculate that now. This is the part I don't know. Okay, so how can I write this in terms of something I know? Well, I know that these two volumes have to be the same. These two, because they're supporting each other, the volume's got to be the same. And I know, so that's going to mean that area times height equals area times height, right? Because area times height is volume. So area of the heavy liquid times the height of the heavy liquid equals area of the light liquid times the height of the light liquid. So if I solve this, oh no, I'm sorry. It's not the heavy and the light liquid. It's height 1 and height 2. I'm sorry. I'm saying the wrong thing. It's height 1. The volume, this volume here equals that volume there, right? I know those two volumes have to be the same, right? Because it just got pushed up from a certain point. So I'll solve for H2, right? So let's do that. And then I'll plug H2 in here, and then I'll have everything in terms of H1. So I'm going to say, if I want to solve for H2, I can divide over the area of the light liquid, right? So H2 is going to be the area of the heavy liquid times H1 divided by the area of the light liquid. So I'm going to take this and I'm going to plug this into here. Okay, so let's see what that looks like. So that's going to be density times G times H1 plus area of the heavy liquid times H1 divided by area of the light liquid equals the number I've already solved. So rho GL, or if you want to solve it, I already know that, right? Okay. Oh, I got to get H1 by itself, right? So see, I have two H1s. Again, like this is the algebra trick homework, right? So let's distribute that out. I'm going to pull out H1, right? So density times G times H1. See how both these things have an H1 term? What could I multiply here, or what numbers could I put here to when I distribute the H1 I end up with this? Well, let's just look at what happens when I make the H1 disappear. So here there'd be nothing, right? So I just got to put a 1 because H1 times 1 would give me H1. And then over here, AH over AL times H1, if I wanted to make that, I'd have to multiply that in, right? So if I took that out, it's just AH over AL. So it's the area of the heavy over the area of the light. That distributes in now, equals density times G times L. Oh, and there you go. Now we're done, right? So the final algebra I will leave to you. So here's a number you know, right? I know the area of the heavy, right? That's this number. So this is area of the heavy. I know the area of the light. This number here is the area of the light liquid. I know 1 is 1, right? I know rho, I know G, and I can solve for H1. You can do algebra, right? You can do that. But not too bad. It was easy until we got to here and had this unknown, right? And then we had to use some algebra like before to figure out, like, how can I take this unknown and plug into another unknown and solve, right? So if you can do that, you can get H1.